to compare these two models, and both models were major improvements for evaluating gene expression, but they approach it in different ways. While the DanQ model used DLSTMs to look at long-term dependencies of DNA sequences, the Informer model uses transformers that evaluate surrounding enhancer or repression sites that may be far away, but could affect gene expressions. Both models achieve successful results by looking at the bigger picture. We start by comparing the architectures, and both inputted hot encoded DNA sequences, and they also both used convolutional layers, but while the DanQ model only used one, the Informer model used 7. Afterwards, they used different layers. For example, the DanQ used a recurrent long short-term memory layer to find physical constraints of elements like enhancers. On the other hand, the Informer model used 11 transformer layers. These layers assign specific weights for different regions, finding enhancers that significantly affect gene expression. This allows for much more accurate gene expression predictions. The outputs of the two models are also different. While DanQ looks purely at the function of DNA sequences, the Informer models can find specific regions that affect the DNA sequence. DanQ is able to predict gene function with about 98% accuracy and identify about 50% of promoter regions, while the Informer model is able to do this, but with much more precision and accuracy, successfully identifying 84% of enhancer regions for a given gene. Generally, DanQ has many limitations that the Informer model overcomes. For example, DanQ can only process sequence of constant length, and it uses a limited amount of input data. The Informer architecture is much more complex and takes longer input sequences. While this requires much more computational resources, Informer performs significantly better. This makes sense because Informer is a much newer model that was conducted in 2021, while DanQ was published in 2016. Overall, DanQ and Informer are both frontline architectures that can help find how non-coding DNA affects gene expression. Thank you for listening to our presentation, and we would also like to thank our mentors Lali and Alexandra for their guidance and support, and we would also like to thank the Primes Computer Science Reading Circle coordinators for providing us with this opportunity.
I guess there were the learning tasks that you tested on.
Then what were you trying to predict? We were trying to predict the gene expression and how the non-coding DNA affects the expression of the gene.
So whether it increases it or represses it or enhances it.
Yeah.
So it's like a positive, negative. I guess whatever it is. Yeah, the higher or lower. And so your overall. So what should I use? I just have, I got to do one thing. What should I use?
The enhancer model worked very well. You should use the transformer layers.
I should use transformer layers?
Yeah.
Okay. Cool.
I know we read DanQ in the spring. How do you guys go about doing the Informer features? Usually got a couple on this physical list, or?
Yeah, we looked at a few more recent ones, and we thought this one had the most similarities in terms of what it was trying to achieve compared to DanQ.
Yeah, I guess it's the exact same goal, but a different method of going about it.
Cool. Thank you.